This example shows how we can use two APIs together asynchronously. Our application will query both the GitHub Jobs API and the USAJobs API concurrently. As we get responses from each of the APIs, we'll parse the results and forward the client a digest. This is why I wanted both of the previous demos to accept the same input and have roughly the same output. The request handler function largely remains unchanged between each of the demos. GetJobsInfo sends requests to both the GitHub Jobs API and the USAJobs API. We've added a new taskCompleted variable used later in the code to count how many API responses we've successfully received and forwarded to the client. In this example, this counter will only count to 2, but can be generalized for any number of APIs. You may ask, why is this variable wrapped in the object options? This variable is placed inside of an object options because I want to achieve pass by reference behavior on it. Primitives in JavaScript are passed by value. Why do I want pass by reference? The taskCompleted variable is used much later in a function Terminate. Inside of jobs information, there are two calls to a function process stream. One by GitHub Jobs requests, and the other by USAJobs requests. Each call to terminate increases the counter task completed by 1. But if it were a primitive, because primitives are passed by value, that increment would be scoped to the function called terminate. Any changes would be lost once exited. I want each of the calls to the function terminate to reference the same task completed variable. Objects use pass by reference, so I can wrap the variable task completed to achieve this behavior. Inside of GetJobsInfo, we've generalized the function processStream into a higher order function. After piecing the stream together one chunk at a time, it executes the past callback function, forwarding variables body, options, and res. When each of the results have been received, two functions, parse USAJobs and parse GitHub Jobs, are called asynchronously. The order of processing from this point is not guaranteed because one of the APIs might have some latency. We will show this by introducing some simulated latency at the end of this demo. The processing of each of these demos is roughly the same as their original, with two major changes. First, instead of using res.end, we use res.write in each of the examples. This change prevents the connection with the client from being closed after receiving just the first response from one of the APIs. After calling res.write, the second parameter executes the function terminate, which will increase the counter task completed by 1. If both tasks are completed, it will send the necessary res.end to tell the client that the transmission is completed. The other major change with these functions is due to the fact that we need to fit twice as much data on the browser's viewport. Each of the results is wrapped in a div block with styling that makes one appear on the left and the other on the right. Let's run this code. If we search Java in New York, we get results from both APIs. If we search Python, also in New York, we get results from only the GitHub Jobs API. If we search Cook in New York, we get results only from the USAJobs API. And if we search Lisp in New York, we get no results from either. It is difficult to see the asynchronous nature in this demo, as the delays between each of the results appearing is at most a few milliseconds apart. We can introduce an artificial delay in our code. HTTP.request does not automatically send the request out. Instead, we need to explicitly make a call to the end method on the resulting connection. If we can delay this call with a timer, it will simulate latency. This will delay the response from the API and subsequently our server's response to the client. We should get one set of results back immediately, and because our server never sends res.end, the connection stays open until we receive the other half of the response after the artificial delay. This triggers the second call to the function terminate, and finally the client will receive the call to res.end. Let's run this again, and let's search Java again. Notice that half the results appeared right away, and the other half was delayed.